How's it going, guys? So in this video we're going to look at the instructions for your final project for the semester. So you'll notice if you look in the weekly drop boxes or in the assignment tab in Ivy Learn, you're going to notice that there's not a whole lot of weekly assignments left. And the reason for that is that we're going to spend most of your assignment time now working towards your final project. So at this point you guys know pretty much everything you need to know to complete the final project, minus probably the ability to create an exploded assembly drawing, which we'll work on probably in week 12 or 13, but it's pretty easy, so I wouldn't worry about that too much. We'll talk about it, but I want to talk about what do you need to know to do the final project, what are you supposed to do for the final project, and then give you some tips and some ideas to kind of get you started. Now the good thing is this is something you can probably work on primarily at home, so you know, if you're not on campus, it doesn't mean you can't do this project. So I'm going to show you some tips for success and things you can use or get your hands on maybe that'll make this project a little bit easier for you. So let's look at what the final project is. If you guys go into Ivy Learn, into the final project instructions, there's a Word file you can open up in there. So when you click on that, it's going to take you to this in Ivy Learn. When you open up that Word file, it's got all the instructions in there for you. Now, I will put the current due date in here, so what is on the Word file may not be 100% correct for you guys, but the due date for your project is going to be listed right here. Okay, so I'm going to double check this date. I believe it should be May 4th. So whatever due date is listed right here in Ivy Learn is the day that your project is going to be due, which should be, if I'm keeping track of the calendar correctly, that should be week 15. So you'll have until the Monday of week 15 to get your final project done, which gives you roughly, I don't know, about 3 weeks to work on it. And it shouldn't take you too terribly long, but you got about 3 weeks to work on this thing. And then the last week of the semester, we're going to devote just to the final exam, which you guys will do online. But I don't want to give you any other assignments during the exam week. So this will be kind of the last thing you guys will turn into me on week 15. And then the following week will be our final exam week. So the due date will be listed right here in Ivy Learn, but it should be the Monday of week 15. So let's talk about what are we doing for the final project. So if you go into the instructions, we'll read through this really quick, but you're going to be reverse engineering something. So the instructions say you're working as a product designer for Mechanized Concepts Incorporated in Phoenix, Arizona. So you got to use your imagination here a little bit. You've recently been informed by Rusty Threadwell, the CEO and head of the MCI brainstorming team, that he's looking for some inspiration for some new mechanical designs. His brainstorming team is stuck in a rut and they're hoping you can provide them with some fresh design ideas. You've been instructed to find a mechanical assembly, measure and reverse engineer it, and present it to the MCI brainstorming team. The CEO hopes that showing the team your drawings will provide a creative spark for their next round of upcoming projects. It's critical that you complete your reverse engineering drawings in time. If you don't, the brainstorming team will not break out of its slump before the next wave of projects starts, which could ultimately spell disaster for Mechanized Concepts Incorporated. So, you know, it's typical world's crashing down, engineer has to save the day type of scenario. Rusty Threadwell has provided you with one example of the type of imaginative assembly he's looking for, a hand screw woodworking clamp, which you can see down here. However, he is insistent that you come up with a mechanical assembly of your own to reverse engineer to provide plenty of imaginative motivation for the brainstorming team. He has also provided you with a packet of rough hand sketches that he created while reverse engineering the woodworking clamp. He has asked that you create your own hand sketches for whatever object you choose to reverse engineer. You should also deliver a complete packet of working drawings in Inventor and either a physical model of your assembly or a high-resolution picture on the deadline. Rusty has stressed to you several times how important this project is. Your reverse engineering skills could mean a big promotion for you at Mechanized Concepts Incorporated. So first of all, don't have a heart attack. We're going to walk through all these things and look at exactly what you need to turn in. And second of all, you've probably figured out at this point that I guess I'm Rusty Threadwell. But I'm giving you all this stuff that you guys are going to use to put this together. So first of all, let's look at what do you have to turn in, and then I'm going to show you examples of past projects as we go through so you can kind of see exactly what you're supposed to turn in for your final project. So things you have to turn in to me on the deadline. A physical model, which obviously we can't do this semester, a physical model or high-resolution picture. So what you guys are going to do is you're going to choose some kind of object, you're going to snap a photo of it, probably with your phone, and you're going to take that and save it in your project folder. So just so I can see the original object. Okay, so for instance, when I did this woodworking clamp, I just started out by snapping a photo of it. So here's the actual object that I reverse engineered. It's called a Jorgensen woodworking clamp, and basically it's like where you can clamp pieces together like if you use wood glue while they're drying. And so you turn these two handles and it causes the jaws on this clamp to either open or close. So you can, put two pieces of wood together with glue between them, and you can take this clamp and tighten them down really, really tight while the glue dries. So that's what I chose to reverse engineer as a sample for you guys to kind of see. So you will take a high-res photo of whatever object you choose. That's the first thing you'll turn in. If we go back to our instructions, you have to have a packet of hand-drawn concept sketches. Now, these to me, they don't have to be as, artsy as mine. I'll show you some student examples in a minute. They're nothing more than a chance for you to kind of get to know this object, because when you look at it, sometimes you don't understand the thing fully at first glance. So when I show you this thing, yeah, you can kind of see what some of the pieces are, but you don't truly understand how it works until you start to really investigate it and take it apart and go through that reverse engineering process. So what you guys are going to do is, you'll take your photo of the thing, then you're going to start to take it apart and figure out, how does this thing work? How many different pieces are there? How do the pieces fit together? What sizes are the pieces? And so you're going to basically make some engineering notes as you go through this. So these are the drawings that I made for this thing as I started to reverse engineer it. And as I go through this process, I'm really just looking at, how does the thing work? Okay, and the drawings can be, if you like to draw, you can kind of do what I did here and really, put some time into them. If you want to just get some quick sketches, that's fine too, but you want them to at least be neat and organized where you can read them. So when I did my hand sketches for the woodworking clamp, what I did is I said, okay, well, how many different pieces do I have? Some of them are the same, some of them are like mirror images of each other. So I looked at this and I said, okay, I've got basically 6 individual parts that I'm going to have to model here, because some of them are duplicates, right? Like this cap and the handle and the pin, those are duplicates. The barrel is a duplicate. The clamps are the same, but they're reverse, mirror images. Same thing with this threaded rod. The threading on them is different so that it will work opposite each other. But anyway, you want to just kind of examine the thing and figure out, how many pieces do I have? How does this thing fit together? From there, what I did is I took it apart into all of its different pieces as best I could, and then I started to measure them. Okay, so for measuring, what I would highly recommend you get, and you can buy this off Amazon, so you really don't need to leave the house, is some kind of caliper. Whether you like a vernier caliper, which I don't, you can get them, they're cheap. You can get a vernier caliper, a dial caliper, which is my favorite, or you can get a digital caliper. I would recommend getting one of these off Amazon. It's going to allow you to measure things to a greater level of accuracy and precision than you can with a ruler. So just for example here, let me run to Amazon really quick. And let's say I look up a digital caliper. You don't have to spend a ton of money. Like, the one I'm using this is my personal caliper. It's a Mitutoyo. It's probably like $120 caliper. But, I bought this thing knowing I'm going to use it for decades probably. So spend what you feel like is appropriate for you. But you can get something even cheap, like down to $20. That'll work pretty well. So, trust your Amazon rating there. But just know that whatever you spend is probably going to be a direct reflection of how good this tool is and how long it's going to last. So you can get all the way down to, $10. Now, is this going to be the greatest one you've ever used? No. Will it get the job done for this project? Yeah, it should be okay. So, you can decide, how much do you want to spend? Do you want to spend $9.97 or $120? So, if you want to buy one that's going to last for the rest of your life, or, most of it, like I did, where I bought this Mitutoyo, these cost a little more. Okay, so this might be the exact one I have. No, that's a little bit bigger. Mine's a 0 to 6. So this is really similar to the one that I have. So $96. So, if you want to buy a really, really good one that you can use for a long time, there's an example of a really, really good one. So, and these will, hopefully ship to your house within a few days. So that is what I would recommend as the number one thing you need to complete this project. So you can spend $9 or $96. It's up to you, but you should be able to get one on Amazon. They are available in stores also, but I know some people are not shopping much right now, so it's up to you. So what you're going to do now is, once you have a way of measuring these things, you're going to take this device apart and start to measure the different pieces of it. So, where are the holes at? How big are the holes? How tall is this thing? How long is it? How wide is it? And then you're going to go in your hand sketches and you're going to start to record some of those measurements. And what that does is it keeps it where you have to jump back and forth all the time from the actual object to inventor. And you can kind of model off of your sketches then instead of trying to constantly measure everything while you're modeling. It just makes it a little bit easier for you. So what I did is I went through all the different 6 pieces and I tried to write down or measure anything that I thought I would need. Okay, so you can kind of see my drawings here. Now, did I get every single measurement that I needed right from the beginning? No. As you start modeling this thing, you're going to realize as you get into that model, oh man, I forgot to measure something, or what's that size? I don't see it. So you may need to, once in a while, go back to the original object, measure it if you missed a dimension on your sketches, and then go back and add that to your sketches and put it into Inventor. But the hand sketches are just a chance for you to kind of stop and slow down and think about this thing before you jump right to the computer and try and reverse engineer it all. So it's a way of causing you to slow down and think through things. Okay? So that's the second thing you'll turn in is your hand sketches. Okay, they do not have to be perfect technical, front, right, top views. Whatever you feel like you need to sketch to get this done is fine. But you can see I kind of followed like the standard drawing setup at least. So the first thing you're turning in is your high-res photo. That's the first part of your project. Whatever you're modeling, take a photo of it. Your second thing is you're going to make your hand sketches. Okay, so that's the second thing you'll turn in. And then the third thing you're going to turn in is all of your Inventor files. So here's mine. Okay, and this, to be honest, I didn't completely finish this, so I'm going to show you a couple of student projects that are better than mine actually. But at that point, you'll go through and you'll model the parts from your drawings. So you'll model all the parts, you'll put them together into an assembly, and then you're going to make a drawing packet or an IDW file with all the drawings in there. So your first page is going to be your assembly page. And then after that, you put all of your part models in there. Okay, and you're going to do this on the METC template. So let me show you some student projects that I think are honestly a little bit better than mine. So this is probably, well, before I show you this, let me show you like how do you decide what to pick, right? Because the one I'm going to show you is probably the best project I've ever received, and it's way above and beyond what I'm expecting you to do this semester. So I tell people to pick something that has at least 4 unique parts. And at least one part has to be a fastener of some kind. So threads or a bearing or some kind of mechanical feature. Okay. So don't pick something that is so ridiculously hard you can't do it. That's not my goal for this. I know you guys are still pretty early in your 3D modeling part of your curriculum that you still have to take METC 220 and learn even more. So pick something that has 4 to 5, maybe 6 parts. So I picked this as an example. This is out of my garage. This is like a gear puller that I use sometimes. So you can see if I take this apart into its component pieces, it's got these 2 arms. Hopefully you can see those up against my dark sweatshirt. It's got these 2 arms, and they've got threaded bolts that go in the top. Then there's another one on the other side just like it. So that's really 2 unique pieces. It's got this kind of this bar in the middle where everything bolts together. It's got a cap that goes on the end. There's an O-ring on here, and then this threaded rod that goes through the middle. So really I've got what? 1, 2, 3 if you count the O-ring, 4, 5, 6 unique pieces. And then, these 2 are a copy. So something like this, I would say is sufficiently difficult. So don't pick something that's crazy difficult. Like I had one student, you'll laugh when I say this, but I had a student one semester that told me they were going to reverse engineer a jet engine in like 3 weeks. And so we had to talk through that and talk about why that probably wouldn't be a great project choice, considering that there were teams of hundreds of, career engineers that work on things like that for years and years and years and years. Probably not going to get it done on your own in 3 weeks for your college final project. So pick something that's doable, okay? It can also be like a sub-assembly of something. So I had a student one time that decided he was going to do a Nerf gun. If I can find a picture here, if I can type today. So he decided he was going to do a Nerf gun, which, if you've ever seen one of these before, we probably all have. He was going to reverse engineer the whole thing, which at first he thought would be a really good project. And then he opened it up and saw all of this inside there. So all these really super complicated injection molded plastic pieces. And he was probably like 2 weeks into the project at that point and brought it to me and kind of said, hey, I picked something that's way too difficult here, and I didn't realize it until I got a couple weeks into this, and I don't think I'm going to get this thing done. And so what I told him was, well, instead of trying to make the entire thing, pick a sub-assembly or like 3 or 4 components out of that you can model. And so what he ended up modeling instead of the whole Nerf gun is he modeled the trigger assembly, which if you lift that out of there, even just this trigger has like, and I don't think it was this exact model, but the trigger assembly that he picked just by itself had like 8 or 10 pieces. And so I looked at that and said, okay, well, that's sufficiently difficult. So it's a sub-assembly of a larger assembly. So you can do something like that also, but it's probably better if you have, some kind of complete assembly of something you can make. Okay, so a photo of your object that you're going to reverse engineer, your hand sketches, and your inventor drawings. A good place to look for objects is like around your garage, around the house. If you got like a junk drawer in your house, you can dig through that. Try to find something laying around. If you like to take stuff apart, grab a screwdriver or a wrench or a socket and start taking stuff apart. That's probably the best way to find something is if you got some junk laying around that you're going to throw out in the trash, take it apart and see what's inside there, and you might be able to find a potential project in there. And then remember, if you have your object and some kind of caliper, you're probably good to go. So now that we've kind of gone through all that, let's revisit our instructions here. So there is one thing I'm going to remove from your project this semester. If you look in the rubric I gave you guys or in the instructions down here at the bottom, it tells you that you're going to give a 5 to 10 minute presentation of your design. We obviously can't do that since we're doing this class in a virtual environment. I'm going to remove that part from the grade. So you guys will be graded just on your 3 things, your photo, your hand sketches, and your 3D models. I'm not going to make you guys give a presentation because there's really no logical way that we could probably do it efficiently. So let's look at a couple of final sample student projects, and then I'll go ahead and cut the video. And if you guys have questions, obviously you can always email me. But hopefully I've done a halfway decent job of explaining this project to you. So here's another one that one of my students did. This one's a little hard to see, but these are his hand sketches. Maybe I should show you the actual project first. So this is the hardest project I've probably had somebody complete so far. You do not have to do something this complicated, but he decided he wanted to go above and beyond because I think he was applying for a job at the time, and he wanted something that he could put into his portfolio for his job application when he went for his interview. So he bought this bench vise and started taking it apart and putting it together and measuring everything. So this is his assembly drawing, which comes first. And again, this is on the METC title block, so it shows the whole thing all put together. Then his next page is his exploded assembly, and we're going to look at how to do these together this semester. So if you don't know how to make an exploded view like this, we'll get to that. It'll probably be week 12 or 13. We'll look at that together. So this does not take very long either. You can make a view like this probably in about 5 minutes. So this is his exploded drawing. It shows his bill of materials with all of his different parts on there. And then from there, they're all just part drawings. So you can see his assembly has 23 different unique parts on it. So from there, the other 15 pages of this document are just orthographic technical drawings of the different pieces. So he's got his front, right, top, and isometric view for each one of these pieces. And some of them are duplicates. So like this one, you can see he left the top view off of. But at that point, you're just detailing out all the pieces with any information necessary to make the thing. Okay, and you probably will not have this many pages in your project because you're not going to pick something that's difficult. But, something like this, you may have like 5 to 7 pages, depending on how many of these parts are unique. So you'll have your assembly drawing, and then one drawing for each one of the pieces that are in there, okay? So if you go back to Ivy Learn, I've got a couple other sample projects in here of different things people have done. So one of these is older. This is a student that did this in AutoCAD several years ago, but I liked his project, so I held on to it. So I'll show you his hand sketches. And then we'll look at his finished project. So these are sketches he did of like the controller and the buttons and everything. And you can see the drawings don't have to be super pretty. It's just a way for you to keep track of what have you measured. Okay, that way when you start modeling, you know where the sizes and the dimensions go. So going back, if we look at his actual drawings now, so you can see this, it looks a little different because it was done in AutoCAD, but it's the same kind of idea. So this shows the controller assembly and the different fasteners that go in there and all the little button pads that are inside there. And then he bit off a little more than he could chew. He didn't have a chance to dimension all of his drawings, so got some points deducted for that. But I like this project in general because of the level of difficulty of it, so I saved it to kind of show to you guys. And then one final one I'll show you. Let me close out some of these windows here. I had another student that did a tape gun like you use when you pack boxes, where you can put the big roll of like packing tape on top of there, and then you stretch it over a box and it tears it off. So unfortunately, I don't have his hand sketches because I gave them back to him that semester, but I will show you his finished project, which is kind of cool. So here you can see his tape gun where you actually load the tape on here, and then you can see the teeth right here where you tear it off as you tape up boxes. So there's his assembly drawing that shows all the pieces put together. Here's his exploded drawing that shows all the pieces taken apart and the name of each one and how many you need. And then from there, it's just all of his individual part drawings. So I posted these in Ivy Learn, so you guys can go kind of for reference and compare somebody else's project to maybe what you're working on or what your idea is. Now again, the 3 that I have posted in there I would look at as probably a very high level of difficulty. You do not have to do something this complicated. They're just ideas to show you what you can do. But this is something you could save for your portfolio when you go to graduate, that you could put in there and kind of use to show to employers or kind of keep and show what you're capable of doing in the software. Okay, so that's it for the final project. When you guys get done, I put a Dropbox in Ivy Learn where you can dump all your Inventor files along with a scan or a photo of your hand sketches and your photo of your actual object. So your 3 things that you can upload when you're done. You can go into the final project Dropbox right here, and this will be 50 points altogether. You can drop it right in there in the Dropbox. So hopefully that explains the final project. If you guys have other questions that I didn't answer for some reason in this video, you're welcome to email me, jhamilton83@ivytech.edu, or you can call my office phone, 317-917-5916, and just leave me a message and I'll email you or call you back and hopefully answer your question. So good luck. Take your time on your final project. Get yourself a caliper that you like and have fun. So I'll see you later.